So that's why I'm saying I think that default should not be any object, because that's a pretty rare case where two different kinds of UI elements are sending the same thing. So why do the rare case? Even though that's the more generic or more general case, I agree, it still just seems kind of error prone to me. But anyway, so there's another any object example. So here's one more any object thing. Let's go back to that button thing. So I told you the button with type returns any object. Okay? And so if I got a button and I wanted to find out its title or something like that, I have to cast it. So I would call I would call that button with type, and I can cast on the fly, right in line. So if I called that line on green at the top, then down here I could say the title of the button equals button as UI button dot current title. So I'm just casting that any object, that button any object up there to be a UI button, and then sending it a message. So you can cast on the fly. Again, crash-a-roo if that button is not a button, but that's okay. In this case, button with type better darn well return a UI button. Okay, now this casting business is not just for any object. You can actually cast any two objects. For all non-any object case, though, obviously those two objects would have to be in the same inheritance hierarchy, right? You can only cast down, downcast into your own inheritance hierarchy. So, for example, if I had a local variable called VC, which was of type UI view controller, but I set it to calculator view controller, okay? I couldn't say vc.enter, right? Enter is a method in our calculator view controller. I couldn't say vc.enter because VC is a UI view controller. So as far as Swift knows, it doesn't respond to enter. Even though it is, in fact, a calculator view controller, from Swift's point of view, that local variable is not. It's of type UI view controller. But I could cast it and say, if I can let the calc VC equal VC as a calculator view controller, now I can say calc VC.enter. Okay? So you can cast, downcast through your inheritance hierarchy as well. You rarely do that, but might occasionally. All right, so let's zoom on here to any questions about that whole any object thing. When you see it in action, it'll make a lot more sense. Okay. Okay, so now let's just talk about some fun functions throughout all our classes, and we're going to start with array. First of all, that you know that array does plus equals. You can say array plus equals, but the argument to plus equals is another array. Okay, so if you just want to add one thing to an array using plus equals, you would have to put it in another array, just square brackets, put the thing inside, okay? Some people get tripped up by this. They do plus equals, they have an array of ints, and they say, my array of ints plus equals an int, and they're like, wow, why doesn't it work? It's because plus equal only adds a whole arrays to other arrays. It's an array concatenator, okay? There's a couple of interesting variables, properties in array, first and last, that will return the first or last item in the array. What's interesting about them is that they return an optional. So they don't do array index out of bounds. So they'll return nil if your array is empty. Okay? So you should know about these because they can make your code read really nicely sometimes. So for these next ones, I'm going to have a little example array here. This is going to be an array that's got 3 things in it. I'm not even going to say what the types of those 3 things in there. They could be anything, okay? Because array is generic, right? Array angle bracket T. You can assume for the purposes of this, they're of type T, whatever the T is that I created the array with, right? So let's talk about, about append. That's how you add something to an array. We did that in the calculator all the time. There's also insert, so you can insert something in the middle of your array. You just specify what index. There's also splice. Okay, splice will take another array and splice it into the middle of your array. Okay, so that can sometimes be valuable. It's otherwise just like insert. It's just like inserting another array inside the array. Okay. There's also remove at index, of course, if it's a var. If you've got your array in a var, you can do remove at index. There's also remove range. Okay, so you can specify a range with the ... thing or the ... less than thing and remove a range of your array elements. And there's also replace range. And when you replace a range, the thing you replace it with doesn't have to be the same length. So I can have an array and replace a range that spans 3 things with something that is 6 long and it'll make my array longer. Okay? So we can replace range. There's also sorting. You can sort an array. This sorting method in array takes one argument, and that's just a function to determine whether two things are ordered before each other or not. Okay, so it's going through the array and putting everything in order. It needs to know, it picks out whatever sort it's using, quick sort, or I don't know what sort it's using in there, but it needs to be able to compare things. So you just provide a function that does comparison, and usually you're going to do it with a closure just like this. You can see this is kind of the default sorting, assuming that this type can just be compared with less than. I would just say a.sort, closure, $0 less than $1. Make sense? And that's going to return yes if $0 is less than $1, and that's what sort wants to know. And it's going to call that closure repeatedly, okay, as it's going through doing its quick sort or whatever. There's also another one called sorted. This is an in-place sort, right? Sorts the array in place. Their sorted will return a new array that is sorted, okay, a copy of your array sorted. More array methods. Okay, so these three are pretty cool. This one's called filter. So filter will give you a new array with all the undesirable elements filtered out of there. And the way you specify which ones are all undesirable is with the argument, which is a function that just returns a bool, whether something's undesirable or not. Make sense? And there's another one you can do by mapping. So this will give you a new array where every single element in your array is mapped to something else. And the thing you map it to doesn't even have to be the same type. So I could have an array of ints, and I could map it to an array of strings. And that's what I've done here. So I have this array of ints, 1, 2, 3, and I've mapped it using a closure that returns the stringification of it to an array of strings. Now you can see incredibly concise language, Swift. I mean, to take an array of ints and turn it into an array of strings, no for loops, no nothing, just, you know, I don't know, a dozen characters here. So you really want to take advantage of some of the things Swift can do with closures, syntax, and things like that. You can also reduce an entire array to a single value. So this one takes an argument which is the initial value you want to start with, and then it just takes a function that takes the value so far and the next element in the array, and you return what the combination is. So you're just combining, combining, combining. So for example, if you wanted to add it up an array, you could say 1, 2, 3, dot reduce, start with a 0, and then my closure is just going to add the next element, which is the $1, to so far, which is $0. Okay? All right, string. So string is a little bit complicated. I can tell by the way already I'm not going to get to the end of this, so we'll finish this next Wednesday on this whole slide package here. But so string is complicated when it comes to indexing, you know, creating substrings and stuff like that. A lot of people are like, oh, I can't even figure out how to make a substring of a string in Swift. It's so complicated. But once you understand that strings are made of Unicode characters, and when you get a substring, you actually don't want a substring of Unicode characters. You want a substring of Unicode characters that are on glyph boundaries. A glyph is something you perceive to be a character. But in Unicode, it could be multiple characters making up one glyph. For example, an accent. So, you know, a lot of European languages, there's accents. Okay, maybe, you know, in French you have accent aigu, right, which is the forward-going top slash. Well, that could be two Unicode characters, E and the accent character. So two characters makes what you perceive to be one glyph. So you can't index into this string, which is an array of characters. That's what a string is. A string is an array of, essentially internally, a collection, ordered collection of Unicode characters. You can't really index by int, or you might be halfway through the accent aigu, and you're getting, you know, either the accent aigu or the E, but not the character. So instead, strings are indexed by this other type called string.index. Okay, now how do you get a string.index? Okay, well, yes, it's saying here. Okay, so you get a string.index by getting the start index of the string. That gives you a string.index that points to the first character of the string. And then you advance it forward however many times you want to go. So in other words, you have to look through the character so that it'll jump over E accent aigu, both characters, to the next one, you see? So you do that with this function. It's not a method in string. It's actually just a function, a global function called advance. And you give it the index, okay, and you tell it how many times you want it to move forward, and it will give you back a new index. So here's an example. I have a string that says hello. Okay, I want to get the index of the L, the first L. Okay, so I say let the index equal advance the start index of that string, go forward 2. Okay, so now it's pointing at the L. It went forward 1 to the E, now forward to the L. And again, if that was EX onto U, it would have gone forward 4 Unicode characters, but only 3 to the third glyph as you perceive it, okay? So now that I have a pointer to that L, I could use, for example, a nice string function called splice. So splice is just like the splice in array. It will splice a string into the middle of another string, okay? And I'm going to have it splice at that index, and that's going to make it be HE ABC LLO. Splice the ABC right into the middle there, okay? So the start index is the magic behind making that work. Also, if I got 2 local variables, start index and end index, which I made by taking advance of the start index by 1 and 6, so this is going to be, I want to be from index 1 to index 6, then I could get a substring. And I get a substring in a string exactly the same like in an array, square brackets, string, square brackets, but inside that square brackets goes a range. And the range, the dot, dot, dot thing, has to have a string dot index on the left and a string dot index on the right, not ints. Okay? So here I got string dot index by doing this advance for the left and a string dot index on the right. And so the substring will be EABCL, because I went from index 1, which is the second character, index 0 is the first, or to index 6, not including index 6. Okay? Everyone understand string dot index now? It's all about advance. Okay? The advance function is the key to understanding how to substring strings. And there's lots of other, once you understand this, there's things like range of string. Remember we used range of string in calculator, and I told you it returned nil if it couldn't find it. Well, what does it return if it could find it? Well, it returns a range of string dot index. Actually, it returns an optional range of string dot index. Okay, that's how, if you used it for your assignment, that's how you used it. You used the optional nature of it, but now you could even use the range nature of it. So for example, if we wanted to get the whole number portion of a string that had a number, so I have, let's say, 56.25 as a string, I want to get the whole number part, I could just say, find me that decimal point, okay, and that's going to return a range, if it can find it, if there's a decimal point in there, it's going to return that range. And I'm going to grab the part from the num's start index. You see the num is the number, its start index, all the way to where the decimal is, not including the decimal. Okay, now I got the substring, which is the whole part. Everybody cool with that? So substringing and string is actually, once you understand this whole index thing, pretty powerful. We could even remove the whole number part, okay, just by using remove range of that same range, not start index to the decimal range. Or we can replace the range with other things, etc. Okay, so there's a lot of string methods there for doing that, and they're all based on that string index. Okay, other string methods, I'm going to start blasting through a lot of this. You can look these all up in the documentation. Some of these it actually gets from NSString, which I'm going to talk about in a moment. You can see that you can find the end index. There's that join I talked about before. Notice that there's 2 int, but not 2 double. Why is there 2 int in string and not 2 double? Anybody have an idea why that is? It's because when you convert to a double, you have to specify things. How many significant digits do you want? How many digits after the fraction do you want? Things like that. And so there's really nowhere to specify that. It would have to be 2 double with a whole bunch of arguments to specify how you want to do that conversion. When you convert to an int, there's nothing to decide. You just convert it to the int, right? To the whole number. So, but notice that toInt does return an optional int. That's because if you say toInt, if you send that to hello, it's going to be nil. Okay? So, string methods. All right. Okay, there's kind of a hidden bunch of methods that you don't even know about, which is conversions using init. So, for example, if I had a double and a float, I could say let x equal int of that double. And I just basically created a floor and turned it to an int. So I converted it. So you can convert things and convert them from one thing to another. It makes total sense with the number values like ints and floats and things like that. And you're going to see CG float next week. That's another kind of floating point number. And you can convert using, there's no toInt or anything. You just create a new one. with the initializer, okay, so the numbers. But you'd also might be surprised, actually if you read the homework carefully, or the reading assignment, you saw this, is that you can convert arrays and strings using these initializers. For example, you can say array of a string, so create a new array, and the initializer's argument is a string, and it will return you an array of all the characters in that string, right? Unicode characters. Or vice versa, you can have an array of Unicode characters, right? And it will, and you pass that to strings constructor, and it will return a string with those things zipped up. Okay? So there's kind of a hidden thing there. Notice that you can't do string of 52.5, but that's okay because you have that backslash open parentheses thing to convert floats to strings. Okay, you can do string of 52 though, because it has 2 int, it kind of knows how to do that. All right, assertions. So assertions, really valuable debugging aid. They basically take a closure as the first argument. It's an auto closure, which means you don't need the curly braces. It's kind of a funky thing, okay? So the first argument is what would be inside the curly braces of a closure. And the second argument is some string that's going to be printed out on your console, because assert, if whatever that thing that was in the auto closure evaluates to, if that's not true, okay, because you're asserting that that's true, then it's going to crash your program. Okay, and print that message out. So it's a great way to make your program crash when things that should be true aren't. Now, asserts don't work when you build your program for release, like to the App Store. When you're shipping to the App Store, asserts don't work. It doesn't even evaluate the closure, okay? It's just ignored. But for debugging, it's pretty good. So I might have a function called validation that should, at this point that I'm executing this assert, not be returning nil. And if it does return nil, then I'm going to crash here. So I say the assertion is that validation should not be nil right now. Okay? So a lot of languages have assert, so Swift does too. Okay, other functions. So there's a lot of functions, and these do not appear to be documented anywhere yet. So this slide might be your only documentation. Now, I'm sure you can find about them on the internet and stuff too, but there's a lot of functions. These are global functions, not methods. They take arguments which are hard for me to explain to you right now, but basically they take arrays and strings and dictionaries, because they take other things that arrays and strings and dictionaries are, those things. But you can look through this list, kind of interesting things. I can combine it with the thing I was talking about at the end there, with the string, passing in an array of characters. I can actually take a string, call reverse, which returns an array of the characters reversed, and then call string to push it back and call it, create a string again. All right. Objective-C compatibility. You know what? We are going to wait and talk about this next time. Very important topic, but I don't want to give it short shrift. So that is it for today. Let me quickly show you this slide. Okay, coming up, no Friday section this week. Next Monday is holiday, no lecture. Next Wednesday, I might not be talking about auto layout next week. I'm not sure. Your homework 1 was due today. Your homework 2 is already posted. Your reading assignment 2 was posted on Monday. All that stuff is due next Wednesday. If you have any questions, I'm here.
For more, please visit us at stanford.edu. Stanford University.
Okay, well, welcome to Stanford CS 193P, winter of 2015. This is lecture number 5. And today we're going to finish up what we were talking about last time and talk a little bit about Objective-C compatibility, because, of course, iOS was originally written in an entirely different language. And so there's a little bit of bridging between the Swift world and the old world. And we're going to talk about an example of using any object, which is property lists. And I'm going to do a kind of a brief demo even, showing you that. Then we're going to move on to a completely new topic, which is views. So views are how we draw and how we handle touch input in our UI. And so we're going to go over that, and I'll be having a demo for that as well. So I'm going to blast through these slides pretty quick. As usual, the demonstration is probably a little more elucidating than some of the slides, because when you see it in action, it's a lot easier to understand. Okay, so Objective-C compatibility. So virtually all the iOS API, this API that was written over the last however many years in Objective-C, is available from Swift, and you can't even tell the difference. Okay, it's just kind of automatically made available. And when they designed Swift, they went to a lot of trouble to make sure that it could be done in a very compatible way so that all of the iOS API would work just fine in Swift. There's a few special data types, though, that they've gone to special care to bridge between the two languages. And this makes using iOS APIs from Objective-C much, much easier in Swift. And so I'm going to talk briefly about those. One is NSString. That is the old way that strings were represented in iOS. And that is bridged interchangeably to Swift's string. You can't really even tell the difference. If you have a method that takes an NS string, you can pass a Swift string in there, and vice versa. Okay? They're just automatically treated as if they were the same thing, even though they are quite different things. String in Swift is not even a class. Okay? It's just a struct. So they've done some miraculous work to bridge these things. NSArray, which is the old array, is bridged to array of any object. Okay, so anytime you see an array of any object in an iOS API, it's because it was an NS array before. Okay? Then NS dictionary is an interesting one. It's bridged to dictionary where the keys have to be subclasses of NS object and the values are any object. Okay? Now, you might think, oh, that's going to be a problem, and I'll explain a little bit why that's not in a moment. And then, of course, int and float, double, bool, they're all bridged to NS number. We talked briefly about NS number. We talked about the NS number formatter and all that. So NS number was the old Objective-C object that just meant any kind of numeric value. And so anything that used to take an NS number, you can pass a double or float or int in there, and it'll just work. Of course, coming back the other way isn't automatic because it doesn't really know necessarily what you want. But you can use the methods like double value or int value, like we use double value in the calculator. And of course, int and float and double are also bridged to the C types, int, float, and double. So you had an API that takes an int, a C int. It'll be bridged to take the capital I Swift int. So this stuff all just works completely automatically, and you don't have to do anything, and it just works. However, if you want to be explicit about the type, you can cast. Okay, so it is perfectly legal to cast a Swift string to an NS string, and it will always work, so you don't need as question mark. Okay, it's all 100% guaranteed cast. And then once you do that, you have an NS string instead of a string, and so you can send it messages that are in NS string. Although you want to be careful with some of them, like length is an NS string method. That doesn't exist on string. It doesn't exist on string for a reason, because we talked about this before. The length of a Unicode string can vary compared to the number of glyphs you'll see on screen. And the new Swift string deals with that, and the old NS string doesn't really deal with that properly. So you got to be careful when you start calling NS string methods that there's not. You want to look for a string equivalent and use that if you can, because it's newer and it does things a little more accurately. But NS array is the same thing. You can cast from an array that you have in Swift to an NS array, and then you can call methods in NS array, like components joined by string, which is kind of cool. It takes all the components in the array, sends them description, takes those descriptions and joins them by the string you pass as an argument. This is the same as the join method in Swift's string. Okay, so you can look at the documentation for string and a string and NS array, but pretty much all the things you can do there, or most of them anyway, are available in the Swift versions. But again, if you're passing them back and forth, it's all automagic, so we'd say. Now, you might get a little concerned about dictionary because dictionary, the key has to be an NS object. And of course, we know that string and array and dictionary in Swift are not even objects. Okay, they're not any object, or and they're not an NS object for sure. But you can still pass them anywhere you want to pass an any object or a subclass of NS object because they are bridged to classes that inherit from NS object, because NS string, NS array, and NS dictionary all inherit from NS object. So that means strings, Swift strings, can be the keys in a dictionary. an NS dictionary, even though it requires NS object, okay? And of course, all three of them can be the values because even though they're not really objects, they are structs, they are bridged to things that can be, okay? So it is okay to pass a string or an array to any object. You won't even notice this bridging 99% of the time. It just happens automatically, but I just wanted you to know that that's going on so you don't get kind of confused when you start seeing NS string, NS array, what's going on. Okay, they're just being automatically bridged for you. All right, so we talked about any object last time, and I'm going to talk about a use of any object, which is called property list. So property list is not a type or anything like that. It's just a term that we use, and the definition of that term is it's an any object. A property list is any object that is known to be, behind the scenes, one of those 6 classes. NS string, an array, dictionary, number, data, and date. Or bridged to with Swift, okay? So why do we define this property list thing? It's an any object. It's kind of unwieldy because you have to do a fair amount of casting, ising, and asing, because any object, of course, to use it, we have to kind of cast it. And so why do we have this thing? 2 reasons, really. One, property list is used to pass data around blind. It's like a cookie, right, in a browser or something. It's kind of this just bundle of data that only the creator of it knows how to interpret it, because only they know what strings, arrays, dictionaries, and stuff are in there. But to everyone else, it just looks like any objects, so they don't know what it is. So all they can do is pass it around to other things. So it's good for blind data passing. The other thing is a property list can be used as generic data structures. Okay, since it's got arrays and dictionaries and numbers and dates and all that in there, you can turn a data structure like our op stack in the calculator brain. It has op enums in there. That's not a generic data structure, but we could turn it into a generic data structure, for example, and then do things with it like write it out to disk or send it over the network or things like that. So those are the 2 main reasons we use property list. And a really good use of property list in iOS is NS user defaults. So NS user defaults is like a really tiny little database, and it only knows how to store property lists. Okay? And it's really for things like settings and preferences, stuff like that. You would never, it's not high performance. You would never use it for big things like images or anything like that. Just property lists, you know, dates and strings and doubles and things like that. It can store and retrieve any property list, and it just stores it like a dictionary, as if the NS user defaults thing itself is a dictionary. And it can store the whole property list, like set object for key, that first method you see there, and retrieve whole property list. Or it can just do little tiny pieces of property list, like it has a method set double that will just set a double for a certain key. Okay? So it's like a dictionary in that it's key value, but it only stores property lists. And the big thing about the way it stores them is that it persists when your app is gone. Okay? So, you know, normally a dictionary is stored in the heap. As soon as your app quits, it's gone. But this stays around so that when your app launches the next time, all the data is still there. So that's why it's kind of like a database, but it's very small, okay, for preferences and settings. Here's how you use NS user defaults. You use this type method in NS user defaults called standard user defaults. This gives you an instance of an NS user defaults. You're always going to use this same instance. It's like a shared instance. We always use the same one. And then you just send it messages like, you know, set object for key, store this property list, and get object for key to get it back. Now, the changes you make in there are automatically saved, but there is a method called synchronize, which is kind of like save, which can force it to save out to disk. Why do you ever need synchronize when it auto-saves? Well, it auto-saves when things happen like your app stops being the frontmost app. It's not, the user switched to another app, and so your app is still there, but it's switched to the background. It'll save then. So it won't always save when you want, and especially when you're debugging, okay? When you hit stop in the debugger, it doesn't save, okay? And so you probably want to throw some synchronizes in there to save this thing out, especially when you're debugging. It's not really that expensive to synchronize, especially if there's not much data in there, which there shouldn't be because it's small. So you can't hurt too much to throw them in there, okay? And yeah, synchronize returns a bool, whether it failed or not, but if it failed, there's not really much you can do. So a lot of times people don't even look at the return value of synchronize. They just synchronize and they pray. But it's only not going to save if like the disk is full or something, which virtually never happens. So. All right, so I'm going to do a little demo here, show you a little more about property lists and also any object, because you've never seen any object in action. And what we're going to do is we're going to add a property to our calculator brain, which gets its program. Okay? So our calculator brain has a program, especially your versions where you added variables to it. It's got this kind of program. It's almost like a little computer program, and you can execute that program, set its variables. It's great. So it'd be nice if we could get that program. But we don't want to reveal our internal data structure, and there's nothing anyone can do with that program. So we're really just getting it as a cookie, and the only thing you can do with it is give it back.